What is the expression for peak-to-peak ripple at the output of a half-wave rectifier? This is a half-wave rectifier circuit with a capacitive filter. This capacitor is the smoothing capacitor which tries to reduce the ripple content. If you observe the output waveform of this half-wave rectifier, from 0 to T1, this diode is on. The capacitor will try to charge to the maximum value of the input voltage minus the drop across one diode, that is Vp minus Vd on. After t equal to T1, the diode input tries to decrease. When input is decreasing, the diode will be off, open circuit, because the voltage at the anode, that is the input, will be decreasing, whereas the voltage at the cathode, that is the voltage across the capacitor, will not be decreasing. So if you see, the difference between the anode and cathode voltages will be less than Vd drop once input starts decreasing. At t equal to T1, the difference is Vd drop, one diode drop. At t equal to T1 plus, as input is decreasing, but the voltage at the capacitor is not decreasing at that rate. So the difference is not one diode drop, difference between anode and cathode voltages of diode. So the diode will be off. So now there is no way that the input will charge capacitor, but the capacitor will try to hold its charge, but it will discharge through this load resistor slowly, like this, with this slope. So now we want the expression for this ripple voltage. If you observe, at this point the capacitor starts discharging through the load, and it will continue till T3, that is the next cycle. Again it will charge, again it will discharge slowly. So that T1 minus T3 or T3 minus T1 is almost equivalent to Tin. Tin means from T1 till T4. So the distance between T3 and T4 is very small. That is, we can say that T3 minus T1 is almost equal to T4 minus T1. With that approximation, we can get the expression as Vr is equal to Vp minus Vd on, that is this value, into Tin by tau, or Tin by discharging time constant, or Tin by RL into C1. If you don't want to do that approximation, then T4 minus T3 is nothing but delta T. You can get the actual expression as, so if you see, this is approximated, so approximated symbol is there. This is actual expression, so equal to symbol is there. Vp minus Vd on into T minus delta T by RL into C1. Whether this delta T, that is the difference between T3 and T4, is small or large, depends on the C1 value. If C1 discharges by a small amount, then the diode turns on only for a brief period here. If C1 value is very large, discharging time constant C1 into RL is very large, it takes large time for it to discharge, the slope of the discharge is very less. So the diode turns on in the next cycle only for a brief period, and hence we can do this approximation.